You're lying, Miss Jams.
Oh, crap. Greetings. It's nobody here. All right.
But it's recorded.
Okay.
Using the link.
Yeah, let me see about how does it work. And here's how you do. Oh, we can hear you too.
Greetings, ladies and gentlemen. We are going to go over some of the metrology practice final sheet. So we have one problem on the board. If you can see it, try to work this one first. It's our first problem. So,
Morning.
good morning. Welcome in. You're just in time.
I hear from them.
Cherry Jam, what's wrong?
Got my workout.
How does it get it in, Lori? Get the workout in. Amen.
I need to.
Come on. In a few short months, you're gonna be like, I did it. I totally did it. All right, folks. Can you see the problems, you guys? Can you see it? Okay. So let's get started then. All right. So the recommended safe dose of erythromycin for a child is 20 milligrams per kilograms per day in 4 equal doses. The child's weight is 33 pounds. The med is supplied in 125 milligrams per milliliter. So we know that the first step is to convert the child's weight to kilograms. We divide it by 2.2, and that gives us 15 kilograms. All right, the next step is to multiply the child's weight times the recommended dosage. So that would be our 15 kilograms times 20. And what do we get, folks?
300.
300 milligrams per day. Now, the recommended dosage also says that this 20 milligrams is divided in 4 equal doses. So we take the 300 milligrams per day and we divide it by
6.
4.
Is it 4?
It's 4 equal doses. Divided by 4, and we come out with 75 milligrams per dose. Okay. How many milliliters will we administer? How many milliliters are we going to administer? What's the setup?
75 divided by 125.
That's right. So now we take our 75 divided by 125 times milliliter, and that gives us 0.6 milliliter is the answer. Mhm. We actually can't determine if the dosage is safe because we have no doctor's order. You understand? So there's no doctor's order to make the comparison. So we're only solving for the recommended dosage range, the daily dosage, and the divided dose, right? And also, how much will we administer? Because how the medication is supplied. So I hope that makes sense.
Is this from the handout that you sent out? Or?
No. No, this is just one I had prepared on the board just for us to go through. Okay, so I'm gonna erase this one.
We're just warming up.
Yes, sir. Yes, you warming it. Okay, let's try another one. The recommended I really wish I had one that's already, if I can slide a board and it's already written, that would be much easier. The recommended dosage of amoxicillin is 20 to 40 milligrams per kilograms per day. Divided in equal doses every 8 hours. The med is applied as 50 milligrams per milliliter. Child's weight is 72.6 pounds. All right, so we're going to solve for the daily dose, the divided dose, and how much are we going to administer?
So it's daily dose.
Daily, divided,
Divided,
or a single dose.
and single.
And then how many milliliters will we administer? So step one is to convert this child's weight, the 7.26 pounds. We divide that by 2.2, and we come up with 33 kilograms. All right, 33 kilograms. Multiply it by our recommended, 33 times 20. 660 milligrams per day. And we also take that 33 weight, we multiply it by 40, and that gives us 1320 milligrams per day. Yeah. And then it also says that it's divided in equal doses every 8 hours. So we're focusing on the every 8 hours. All right. So that means that we have to take the 660 and divide it down to the single dose. All right. So we're going to divide it by 3 because 8 times 3 is 24. All right. So we take our 660 divided by 3, and we come up with 220 milligrams. We take our 1320 divided by 3, and we get 440 milligrams per dose. This is per dose. So here is our safe dosage range or single dosage range for the child. And how many milliliters will be administered for a single dose if the child, here's the ending, if the child is receiving 20 milligrams per kilograms per day, if the child is receiving this dose. Okay, so if they want us to calculate it based on this one, then we would take the 220, right? 220. And then we divide it by 50 times milliliter. And we come up with
4.4.
4.4 milliliters.
Should 15 cents?
50.
You're right. 5.
Oh, 50. I'm sorry. Thank you. 50. Okay. Are you guys good with this one?
So why again are we only doing it for the 20.
because that's what the question asked. Yeah, because the ending of the question ask us, it says, how many milliliters will be administered for a single dose if the child is receiving a 20 milligrams per kilograms per day dosage,
Got it.
right?
Okay.
Because we can't do it for both. It has to be one or the other. All right. All right.
So that's the single dose, that's the divided dose,
Mhm.
that's the daily dose.
Mm-hmm. All right. So now we can get to the packet now. But I wanted to go over these.
You guys, you don't have extra.
I can, you want to go make a cup? Everybody got? Oh, okay. All right. All right. I emailed out the copies. So everyone should have one. All right. And I completed them so we can move faster. I actually did them all. Who's on live with us this morning? Who's live? Oh, Fatima, Rosalie, Danica, and Fatima. All righty. Good morning. Good morning. Okay. So number one is very simple. All of these, maybe not every problem on here, but these types of problems will be on the metrology final, okay? So you will be asked to convert. Number one says to convert, like 1 liter is equivalent to 1,000. We times this by 1,000, all right? So 1 liter is equivalent to 1,000 milliliters. Very simple. And I have to go over every problem and write it out because some people may not understand. All right. 1 kilogram is equivalent to how many grams? 1,000. We're going from largest to smallest. We multiply by 1,000. So 1,000, 1 kilogram is equivalent to 1,000 grams. Number 3, 3,120 micrograms is equivalent to how many milligrams?
3.12.
Exactly, 3.1. Rounded to the nearest tenth. So we divide, we're going from smallest to largest. We divide it by 1,000. It comes out to 3.12. We round it to the nearest tenth, 3.1 milligram. Number 4, 5.2 kilograms is equivalent to how many grams? I'm going to take the 5.2, we multiply it by 1,000. We're going from largest to smallest, and we come out with 5,200 grams. So number 5 just involves writing the proper metric. So the metric that involves volume would be liter and milliliter. The metrics that involve weight would be grams, milligrams, micrograms, kilograms. I should have went from largest to smallest. Kilograms, grams, milligrams, and micrograms.
But you want it smallest to largest, right? Because that's what it says here.
Yeah.
Oh, from smallest.
Okay, thank you for pointing that out. So it'll be micrograms, milligrams, grams, and kilograms. Thank you, Nurse Lori.
I'm awake.
And she just worked out too? Okay, her blood is pumping to that brain. All right, number 6. In international time, 4:08 p.m. is 16:08. 16:08. All right, so another conversion, 134 pounds is equivalent to how many kilograms? We're going to convert pounds to kilograms, we have to divide by 2.2, and we come out with 60.9 kilograms. All right, another one is 20.8 kilograms. We're converting that to pounds, okay? So we're gonna multiply that by 2.2. We're going from kilograms to pounds, multiply by 2.2, and we come up with 45.76, rounded, 45.8 pounds. All right. Number 9. A client is to take a medication every 6 hours. The first dose is administered at 6:30. What time will the client take the next 2 doses in traditional time? A is 12:30, and then B, international time.
24.
Huh?
24? Oh, no, never mind.
12:30.
The same.
The same
yeah.
thing.
6 hours. 6:30.
But
It's every 6 hours. So it's asking you for the next 2 doses. So one is going to be in traditional time and the other is in international time.
So 12:30
And
and then 6:30.
18:30. 18:30. So
Wait,
9.
traditional time is just regular time, right?
yes, 12:30, and then international time is 18:30.
So the
It's
A
like-
shows is 12:30 p.
12:30
PM?
p. Noon, 12:30, and then B,
Ms. Chubb, it says next 2 doses, so you would need the next 2 times for each one.
So 6:30.
That's it.
30 and then
That's it. After 6:30, the next dose is, the next 2 doses are at 12:30, and then,
18:30.
right.
Got it.
We're good?
Mhm.
Okay. I know, right? That was kind of like,
So what's that?
to make you think. All right, number 10, folks, we are on number 10. Number 10, the 6 rights. We have 6 rights. Now remember, if you break any of the 6 rights, you have committed a medication error. So first we have the right patient, right medication, right dose, right route, right time, and right documentation. I'll repeat it. Right patient, right medication, right dose, right route, right time, and right documentation. All right, number 11. Number 11. A nurse enters a room to administer medication to a client. The order is for prednisolone, 2.5 milligrams twice a day. The nurse administers prednisone, 25 milligrams PO. Now, which of the 6 rights have been violated in this order?
Those.
The dosage has been violated because prednisolone says 2.5, but we're giving 25. What else has been violated?
Time?
The medication. Those are not the same medications.
Oh.
Prednisolone and prednisone are not the same.
Almost the same.
You see it? Okay. So now we're moving on to number 12. Number 12. Give the abbreviation for the following. Twice a day is BID. Every hour is QH, or you can actually just write out every hour now. That's the new conversion now. The abbreviation, they want you to write it out. Every 4 hours is Q4H. Every 4 hours is Q4H. What'd you say it was?
4 times a day. QID.
Oh,
What's
QID.
again?
QID is 4 times a day. This one is every 4 hours.
I didn't hear that.
That's fine. All right. Immediately is stat or now. Right now. All right. Number 13. Number 13. 13A, if we look at the handout for 13A, the trade name is,
Zofran tartrate?
Ambien.
you tried. The
And-
trade name
Trade name.
is Ambien,
Ambien.
because we know why. Okay, it's because it's in all capitals and there's the trademark sign next to it. See the little circle there? The R or the T, it's a trademark sign. That's how we know. Okay, now the generic name is Zolpidem. That's the trade, Zolpidem tartrate is the generic name. And usually the generic name is in parentheses under the trade or the brand name. Okay, and what's the dosage strength?
5 milligrams.
5 milligrams, good. All right, what's the form?
Tablets.
Tablets, okay. Total amount in the container?
100.
100, okay. On to number 14. Okay, so someone has asked me for the handout. Didn't I email it? I emailed the handout. So I emailed it to everybody, okay? All right, so we're moving on now to number 14, 14A. Trade name is,
Nothing.
there is none. There is no trade name.
Oh, because there's no.
There's no trademark sign anywhere next to that bumetanide. Okay, so the generic name is bumetanide. C, the dosage strength is
1 milligram?
1 milligram per 4 milliliters. The whole thing. The whole thing. Okay. C. I'm sorry. D. What's the form?
Injection?
Injection. Good. Injection. Because listen, some people would get the route and the form mixed up, right? When you're dealing with injection, because the route is IM and IV. You see? So form has to be injection. You understand? Okay, so total volume? 4. Total volume is 4 milliliters. It's a total volume. All right. F, directions for use. For IV, IM use. Good.
What's the 0.25 milligrams per ml for Miss Jones?
It's just telling you what each milliliter contains, the mixture.
Oh, because
But
it
you
comes
want
out
the
through the
total.
vial, right?
Right. Yeah, it's just, yeah. Okay.
Every vial is 0.25.
No, because that tells you at the very top on the right corner, it says a 4 milliliter vial. Total volume. So it's 4 milliliters total in that one vial. Okay. I think the other writing specifies how much of what percentage of bumetamine is in the solution and things like that. It gives you the breakdown. All right, so we're moving on to number 15. Okay, online. You guys have questions? Okay. Number 15, Cadian. All right, trade name is Cadian because we see the trademark sign right next to it. Generic name, morphine sulfate. The form,
Capsules.
what's the rest? They're extended release capsules, right? Because that's a difference between a capsule and an extended release capsule. Okay, their functions are different. All right, so it's an extended release capsule. Controlled substance schedule? 2. Okay, it's right on the right side.
So on exam, we're just gonna put 2, right? No more C.
No, you want to fill in. I have to. I don't know. It'll just be a circle. You have to just select it. I don't know. All right, moving on to number 16. Number 16. The generic name, terbutaline. Dosage strength,
Is
1.
1 milligram per milliliter. That's the dosage strength. C, total volume,
1 ml.
1 ml. 1 ml. Directions for use,
Injection. SC injection.
yes, for subcutaneous injection. Very good. All right, so we're on to number 17. Round to the nearest tenth unless otherwise indicated. And we don't have to use ratio proportion for this, okay? So for number 17, the order is for Amoxicillin, 0.5 grams, PO, every 6 hours. What you have available is Amoxicillin capsules, labeled 250 milligrams. Okay. How many capsules will we administer? So we always have to convert what we have, what the doctors order. We always convert the doctor's order to what we have in our supply cabinet. So we have to convert grams to milligrams. We're going from largest to smallest. We multiply by 1,000 and we come out with 500 divided by 250 times capsule. And that gives us 2 capsules. All right. On to number 18.
17.
We have, thank you. We're on number 18, right?
Mhm.
All right. Zofran, 7 milligrams. What we have on supply is Zofran, 4 milligrams per 5 milliliter. All right, so there's no conversion necessary. It's just 7 divided by 4 times 5. And the answer comes out to
8.8.
8.75, rounded 8.8 milliliters. I'm hoping that everybody gets a 100 on the metrology final. That would be super. That would be super. All right, so number 19 is clindamycin. The clindamycin, 0.6 grams. I'm just going to shorten it, okay? What we have available is clindamycin, 300 milligrams per 2 milliliters. So we should always convert the order to what we have on supply. We're converting grams to milligrams. We're going from largest to smallest. Multiply by 1,000, and we come up with 600 divided by 300 times 2. And that gives us 4 milliliters. Okay. We're doing good. We're doing good. Number 20 is amoxicillin, 0.375 grams. That's what the doctor ordered. We have available amoxicillin, 250 milligrams per milliliter. So we already know when you see per milliliter, it's going to end in a decimal. All right, so we have to convert grams to milligrams. We're going from largest to smallest. We multiply by 1,000, And that gives us 375 divided by 250 times milliliter, 1.5 is the answer. Very good. We're doing good, folks. We're doing good. I didn't have my big marker, you guys, online. It's in my other bag, so I had to use the small marker. All right, the order, number 21. The order is for Ticor, 134 milligrams. What we have on the label is 48 milligrams, which is very simple, right? So we're just dividing by 48 times tablets, and we come out with 279. So listen, you guys, I was reading up on these articles or these on rounding tablets, right? You can only do it if the tablet is scored, right? So it says that anywhere between, if you come up with, how did it read? Oh, sorry. Anywho, this would be rounded to 3, according to what that handout said. But I wasn't certain with that because you're giving more than what's required. So, anywho, but your answer book says 2. But if the tablet was scored, you would give 2.5, right? Because the tablet is scored and you can round it, right? Instead of coming down to 2 tablets, you can give 2.5 if the tablet is scored. You understand what I mean? So here is a tablet, a score, down a line down the middle, and you can break it. It can be broken. So if the doctor said, if the calculation came out to be 2.79 and the tablets are scored, you can give 2.5 instead of dropping it all the way down to 2 tabs, according to what the answer says. We'll get back to this. This won't be on a test.
Huh?
This particular problem won't.
Okay, so the answer is going to be.
The answer in your book says 2, but after reading those handouts that I was kind of looking into it about rules for rounding tabs, it says that you would give 2.5 of a tab, right? Yeah, you would give 2.5 only if it's scored. If it's enteric coated, if the tablet is enteric coated, then you would have to give 2.
So it would indicate on here on the label that it's.
Now, sometimes, like for this one, this Tricor is not a scored tablet. Now, if it gives you that information that is scored, or it notes it in the problem that the tablet is scored, that's your hint that it can be cut. So, but if it's enteric coated, you can't break it, right? So you would have to go down to 2 tabs. But if it was scored, you can give 2.5 of a tab. Does that make sense? Okay, we're moving on from this one. We have a whole lecture on this here. Okay, number 22. Number 22, the order is for Viaxin, 175 milligrams. What we have on the label is Viaxin, oral suspension, and it reads 250 milligrams per 5 milliliters. So we know that there's no conversion. The metrics are the same. So it's 175 divided by 250 times 5 milliliters. All right, that's the setup. The answer comes out to 3.5 milliliters. Okay. Does anybody online, you can type in your question if you have a question. Okay, so I guess not. They're not talking trash, so we have nothing to say. Everybody, I don't hear nothing from Danica. All right, so moving on to number 23. Furosemide is the order. Furosemide is Lasix, a loop diuretic, 15 milligrams the label says 40 milligrams per 4 milliliters. The setup is simple. I noticed that students miss the most simplest problems because they don't read it. Because they don't read it.
I caught it after.
Times
Can I go back?
4.
No, you can't.
I know.
You know what, for the final,
Can't
let me
do
tell you,
that.
for the final, I might allow it just for the final.
Thank you.
So that way you can go back and review senseless mistakes.
Just review.
Just to review it, like for example, when we take the final, because usually it's supposed to be sequential, I'll make it free. So that way you guys, if you want to go back and review all your answers, because this test is important.
Just review, you cannot change the answer.
You can change it,
Okay.
yeah. I'll leave it open so you can go back and look at your answers and review from start to finish. You appreciate that, Clark? Clark, you appreciate that? He's like, what? Oh, yes. All right, so 15 divided by 40 times 4. But somebody remind me to do that though, okay? Because I'm in the habit of doing it. So listen, people online, I'm saying that for the metrology final, I will make it so where you guys can go backwards and recheck your answers. Just this time, because the metrology final is very important and you must pass. So some of you are nervous and you might make a mistake, you miscalculated or something like that. I'll let you go back and review your answers or change anything that you got wrong. Okay. All right. So let's move on. That way that'll eliminate some of the stressors of taking this test, right? All right, so number 24. Number 24, the order is for Vancomycin. 0.6 grams IV every 12 hours. What you have on hand is 500 milligrams of vancomycin. So you have to convert grams to milligrams. You multiply by 1,000 because you're going from largest to smallest. And that gives us 600 divided by 500 times milliliters. Answer is 12 milliliters.
1.2.
Oh, is it?
Mhm.
That's my bad. I forgot my, really?
Yes, Miss Joe.
Yes, Miss Jo.
Oh, you know why?
Why?
Let me tell you, okay, correction, people. This is what I overlooked. Because it says after reconstitution is 50 milligrams. So it should be, my bad, 600 divided by 50 times the milliliter. And that comes out to 1.2, right? Is that right?
No, Miss Joe.
No.
What'd that come out to?
Well,
So that's the answer, 12. Right? Let's start over with this one.
oh, because we were doing it. with the-
You're looking at the label, right?
Yeah.
But you see where it says, sorry, folks, you see where it says after reconstitution. After it's all been mixed up, the dosage is now 50 milligrams per milliliter. So now you would take your 600 divided by 50 times milliliter and you will come out with, I was
Well,
right. Sandra, you were right, Sandra.
We were just answering what's on the board.
So what will
Because
happen
it's,
is-
you see there, right here, where it says after reconstitution?
So reconstitution, Miss Joe, is like.
Means that the
mixing.
medicine has been mixed up and the dosage has changed.
Okay, so it would be 600
Divided by 50 now,
instead of
the 500, because that dosage is no longer valid.
That's why it's
So I was right.
the.
You hear that, people online? I was right. Let's see. All right. And I actually did it the other way first because I overlooked that 50. I didn't see that at first. Yeah. All right. So now we're moving on to number 25. All right. Now it's difficult to write this one on the board. Okay. So the doctor's order is for cefazolon 0.375. Okay. A says how you will see this label on the test. And I'm not sure of which part of this label you will be questioned on. Okay. I don't know. But A says, how many milliliters of diluent will you add?
2.5.
Which is 2.5 because it says it on there, 2.5. B, why will the reconstituted volume be larger than the diluent? Because you're adding to it. You're adding volume. Because you're adding volume. All right. C, what is the dosage strength of the reconstituted solution? What's the dosage strength?
So
It's reconstituted now, so it's no longer 1 gram up there.
it'll be 3 ml.
330. Very good. It's 330 milligrams per milliliter. That's the strength. Clara, thank you for my coffee. I said I'm gonna really enjoy that on my way home. I've never had Dunkin' Donuts coffee before. No. So thank you, Claire.
You're welcome, Miss Chubb.
Mm-hmm. D, what are the directions for use? IM or IV use? How many milliliters will you administer? So the doctor ordered 0.375 grams. So now what you have available is 330, right? That's the new dosage on the label, 330 milligrams per milliliter. So you have to convert that 0.375 grams to milligrams. You're going from largest to smallest. You multiply this by 1,000 and it comes out to 375 divided by 330, and it comes out to, it rounds to 1.1 milliliter. It come up to 1.13 something, right? So we round it and it's 1.1 milliliter. All right, you will definitely see this label.
The number 25, Miss Jones?
Yes. Mm-hmm. All right, number 26. We're moving on to number 26. Number 26, the order is for Zithromax 250. A, how many milliliters of diluent must be added to the bottle? 9. It says it on the label. Remember when you're dealing with a reconstitution that the instructions are always on the label or in the insert. B, what is the final concentration of the prepared solution? So it's 200 milligrams per 5 because there's no other dosage strength on there, right? There's nothing else. There's no other dosage strength. So it's 200 milligrams per 5 milliliters for B. C is how many milliliters will you administer? So it will be what the doctor ordered, which is 250 divided by what's on the label, 200 per 5. And the answer comes out to be 6.25. We round it to the nearest 10, 6.3 milliliters. You might see this one, a similitude, something. Okay, moving on now to number 27. The trade name is Levemir. I feel like we did this label already. B, the generic name is Detamir. It's small. That's what it say though.
How do you spell it?
It say Detamir, DETE, I think, MIR.
Is it insulin?
It's insulin.
So insulin is part of the generic name, Miss Chubb?
No,
Just the
That's
determinant.
a type.
Levemir is the brand and Detamir is the generic name for the insulin. Directions for use. We know it's sub-Q, right? It's sub-Q, subcutaneous use. D, is this a short or long-acting insulin? Okay, so we have rapid acting, or we call it fast acting. We have short acting. So let's do a little spiel on this insulin really quick. You have to be able to identify your insulin, folks. So what is units dash 100 represent? What is the interpretation of this? It's 100 units per milliliter. That's what this means. It's 100 units per milliliter. This is the concentration, right? Or the dosage strength. Okay. So insulin we have fast acting. We have we have short acting. We have intermediate acting. And what's the last one? Long acting. And we have long acting insulin. Fast acting insulin, which is your Lispro. Lispro is one of the common fast acting insulins. Lispro begins to work in 5 to 15 minutes of administration. So this medicine, this medicine can be administered 5 minutes before meals, prior to meals. A patient can receive this fast-acting insulin. It works within 5 to 15 minutes, and it can be administered 5 minutes before the meals. Okay, so we don't give insulin after they eat it, right? They're eating lunch now. You missed them, and you go, what's right? Okay, the peak time for this one is 1 to 2 hours. That means the medicine hits its peak in 1 to 2 hours. Lispro. Okay, then we have our short-acting insulin. Our short-acting insulin starts to work in 15 to 30 minutes for the patient. All right, and you need to give this medicine 30 minutes before meals. Short-acting. Okay. Then we have our intermediate is what? An example of that, our INA, our NP, oh, Jesus. Our NPH, right? What's one of the characteristics of NPH insulin? What does it look like?
Cloudy.
It's cloudy, right? It's cloudy. This is clear, and this one is clear. Clear. Okay. NPH is it's cloudy. All right. So what is one of the things you have to do before you use NPH? What do you have to do with it? You have to mix it. Why do you mix it? Right? It's a suspension. And there's a powder sediment at the bottom of the vial. So you have to mix it. You never shake it, right? Because what happens if you shake the insulin? It's going to create bubbles, and it's going to break down the particle. It's going to break it down, okay? So with NPH, it must be mixed first between your hands until the powder on the bottom disperses, okay? The onset, okay? What's the action time of NPH is 1 to 2 hours. Starts to work in 1 to 2 hours. And the peak time, this is important for you guys to know. The peak time is 2 to 4 hours, or sometimes 2 to 6. The peak time, it reaches its peak, okay? Then we have long-acting insulin. An example of that is Lantus. Lantus is a long-acting insulin. Lantus is long-acting. One of the characteristics of Lantus is that it must be given at the same time every night. Same time. So if you choose, usually it's given at 6 p.m., okay? It's usually given at 6 p.m., all right? This medicine works overnight for our non-compliant diabetics, those who like to eat a little cookie at 10 p.m., or they eat some candy, right? They wake up and they eat candy, and then you go assess their blood sugar in the morning, and you're like, wow, their blood sugar is 300. What were you doing? Nothing. They ate a sandwich. They had a sandwich, all right? So long-acting insulin, it must be given at the same time every night, okay? And this medicine cannot be mixed with any other, it cannot be mixed. It cannot be mixed. The action time is 1 to 2 hours, I believe. I believe it's 1 to 2 hours, the action time. Okay, but the peak time is 6 to 24 hours. So it works
24 hours.
overnight, all right, to help our patients out.
You said peak is what, 24 hours?
6 to 24 hours. Some books say 6 to 20 hours for peak time. Okay, so this is the standard rubric, you guys, for insulin. All right, and yeah, go. And you need to know it. This is important. You have to know your insulin. All right, you need to know the types of insulin. That's important. Okay. Is there anything else? All right, so let's talk about really quick mixing the insulin. All right. So what's the purpose of mixing insulin? Why do we mix insulin?
So
Anybody know?
Just give like one shot and not go to the
We mix insulin to help patients. Why do we have, pre-mixed insulin? That's what I meant to say, pre-mixed. You know, we have insulin already pre-mixed in the vial. Here's the, here's the vial, right? And it says 70-30 on it. That's a pre-mixed insulin vial. Why is it already pre-mixed? What's the purpose of that? It's for patients who are not able to properly mix their insulin themselves. Some patients have a poor hand dexterity. They can't mix, so the vial comes pre-mixed. So when you see, let's say you see 70-30 on an insulin vial, it'll tell you that the 70 in the vial is 70% NPH in this vial, and it's 30% regular insulin.
Oh, so they don't need to mix it.
They don't need to, because it comes pre-mixed.
Oh.
They have several types of pre-mixed insulin. Now, but if the doctor wants us to mix the insulin, right? The patient's in the hospital and we're going to mix insulin for the patient, right? All right. So we have our regular and we have our NPH. This is what the doctor wants the patient to have. 5 units of this and 5 units of NPH. What's the first step?
Air.
To inject air, equal amounts of air equal to the dosage. So where do we inject air first?
Well,
In the cloudy. All right. So we inject air here first. Air second, right? Now here's the thing. Why do we inject air in the cloudy first?
that's concentrated.
It's because we don't want any NPH to get into the regular. Because if we go this way, if we get regular in NPH, we alter this, right? So just remember, I don't want to make it complicated, but the purpose, when you put your needle into the NPH, make sure your needle does not touch the insulin. When you're injecting air, make sure your needle does not touch the solution, the insulin, when you inject your needle to retrieve air.
Injecting it,
That's why it's supposed to stay down,
Oh.
right? Inject your 5 units of air and take it out. And then you inject 5 units of air here and invert it. You never want the regular to become contaminated with NPH because it loses its effect. It needs to stay clear. It needs to stay fast acting. But if it's contaminated with this, it's going to alter this. Okay? You understand what I'm saying? Okay. So the air second. And then once we inject our air, then we can invert it. And then we go from clear to cloudy from here. Now we can pull out what we need. We can pull out our 5 units. And then we take it out from here and go directly into here. And we take out our 5, which is a total of 10. Right? That's your quick review. So once we mix the insulin, we must administer it within 15 minutes. Why? We just mixed the insulin together. It must be administered within 15 minutes. Why is that? Anybody know? Okay, I'll tell you. All right, it's because the regular insulin binds to the NPH and changes its properties. So that's why it must be administered within 15 minutes when you mix it. Because the regular insulin binds to the NPH and changes its properties.
So what happens if you go over?
Then it needs to be redrawn. Need to do it over. Because everything is changing now, right? So that's free.
Okay, so going back to number 26,
Uh-huh.
27.
Yes.
So is this a short or long acting?
Thank you. This is a long acting. Levemir is a long acting insulin. It works overnight.
So how would we know that by reading the label?
Well, you would have to know by reading your book. You have to know that.
But we're not
So
going
we
to
need
basically
to know by,
It's not going to tell you on here.
You said about like if the label does have an R on
Miss
it.
Peggy's
Yeah,
chart.
because
What is that?
now some of the insulin labels, one has an R for regular, one has an N, but you won't see an L on an insulin label for Lantus, right? So you would have to be able to identify your insulin labels. Now let's find an insulin label. I know we have another one, but I've never seen them indicate that it was a long acting unless you read the bottle on the back. Okay,
okay, so that one is a long acting?
it's a long acting. You see a label or something? And also, insulin cannot be frozen. We never freeze insulin.
Or
Okay. All right, you guys. Let's move on to any more questions? Are you looking at what you looking up, Lori?
My notes, because I do screenshots of my notes.
Because I actually gave you guys a handout on insulin.
I have it in my.
Okay.
backpack.
All right. Number 28. These are IV fluid abbreviations. D5 normal saline. What is the interpretation of that one? How should it be written?
What is
5% normal.
Yes, it should be written like this, 5% dextrose. Normal saline. That is the interpretation of D5 normal saline, D5NS. It's 5% dextrose and normal saline. Okay. All right. What they saying? Here we go. Number 28. I'm sorry, 29. 29. The order is for Zofran, 2 grams in 100 milliliters of D5W over 40 minutes. You will see a lot of problems like this on the metrology final.
So
Okay.
For the, is there a specific formula for the flow rate?
Here it is. Milliliters infused. It's only 2 divided by hours. And the other one is milliliters infused
Is it the drop top or something?
divided by minutes times drop factor.
That's the thing.
These are the only 2 formulas we have. So if there's no drop factor here, you already know you're using this one, right? So if it's milliliters and hours, we got milliliters, but where's the hour? So what do we do with this 40 minutes? We have to convert it to hours by dividing it by 60. And we come out with 0.6666. So we'll say 0.66 hours. Okay, so now the setup is 100 milliliters divided by 0.66. Okay, and that gives us 151.5. We rounded to the nearest whole number, 152 milliliters per hour. So remember, this one is going to come out in milliliters per hour, and this one comes out in GTT per minute. All right, so you know if they're asking you milliliters per hour, you're going to use this one. Yeah.
Oh, I think, I was just confused with it.
Yeah. Okay. All right, so you're going to see a lot of number 30. Number 30. And the thing is, that's what got you, Jerry Jan, number 30. Because, right, it's very simple. So the order is 0.33% normal saline at 200 milliliters per hour. Okay. The drop factor is, for A, is 10 GTT per milliliter. Okay. So sometimes it'll be just like this. You had 3 problems like this, and it threw some folks off. So what do we have to do? What's the setup for this one?
200 divided by 60.
Because there's no time on here, right? Here's the 200 to be administered. There's 60 minutes in an hour times the drop factor, which is 10. And it comes out to, it's 33 drops per minute is the answer to this one. 33 drops for A, right? Okay. B, it's the same setup. 200, that's the best thing about this. It's the same setup. All you're doing is changing the drop factor. So it's 200 divided by 60 times the next drop factor, which is 15, and it is 50 GTT per minute. The next one, same setup, 200 divided by 60 times, 20? And the answer comes out to 67 GTT per minute. And the last one, 200 divided by 60 times the last one is 60, and we come out with 200 GTT per minute. I think it came out to 199 point something.
0.99999.
Yeah. So that's pretty much it with this one. And you will see these, so don't let it trip you up. Don't let it mess you. Jerry Jam, you own it now. You got it now.
I forgot the formula.
Uh-huh.
Forget to divide.
You forgot the 60. All right, number 31. The doctor orders 250. This one has always been a problem. You will see problems like this. Number 25, 250 milliliters of packed RBCs in 4 hours.
That's like, what is that, transfusion?
Yes. A is asking you how many milliliters per hour, this formula. And B is asking you for the second formula, which is drops per minute. And is giving you the drop factor, which is 20. Okay, so we're going to solve for milliliters per hour, which is simple. It's 250 divided by 4. And we come out with 62.5. And we round it to 63 milliliters per hour is the answer. Okay, 63 for A. B is now solve for the drops per minute, and here's the drop factor. So what do we do now? We have to convert these hours to minutes to fit into this formula, right? So we convert the 4 hours, we divide it by 60, and it comes out to 240 minutes. So now we have, the setup is now 250 divided by 240 times the drop factor of 20, and that gives us, so we round it. Let's just round it right away. 21 drops per minute. Now this one, you will see. So be careful. You good on this, Jerry Chan?
I hope I'll remember.
Yeah, but listen, look at what, all you have to remember is what it's asking you. You know how to solve for milliliters per hour. It's this formula. Here's the hour, and there's the milliliters. Now it's saying the drop factor. Now we're going to give you it with the drop factor. So it's the same thing. Milliliters, convert this to minutes, and then times the drop factor.
That confuses us sometimes for the conversion of
Yeah, you got to get that. Yeah, I understand. You got to get that brain to working. It's training your brain. Believe me, you'll get better. All right? We're doing good. We're doing great. Oh, okay. So I made the mistake of adding number 36 is not one of your problems because that's a heparin calculation, and you guys will not be given heparin like that. So 36 people on the handout, Eva, cross it out. Okay, because Eva will say, Ms. Chubbs, number 36. So no 36. We're not doing that at all. All right, so let's move on now to number 32. 32, we talked about, this is the most simplistic heparin calculation. The order is for 40 units. 40 units per kilogram per hour. And I don't even know if this might be on the test because you guys won't be given heparin, but let's just say, just know it. The weight, the weight is 116 pounds. And it says, how many units should the client receive per hour? Very simple. All you're doing is converting the weight to kilograms. We divided by 2.2 and we came out with 52.7. And all you're doing is multiplying this times this. 52.7 times 40. And that gives us, what is it? 2,108 units per hour.
And that's it?
And that's it. It's too easy, huh? It's so easy, it's hard. Units per hour. All right. Now we're moving on to number 33. It's the same principle. Same principle with the next one. 33. The weight is 220 pounds. We convert that weight. It comes out to 100 kilograms. And all we do is multiply by the 14 units. Comes out to 1,400 units per hour. Simple, 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 simple. All right, so we're not doing 33 or 30. Wait a minute. Why did I scratch that out? No, we're not doing 34 because we're not giving heparin IV. We're not doing 34.
Cross it out.
Let's cross it out. Cross out 34 and 36. Okay, so let's do number 35. 35 is on the same vein as 32 and 33. The client weighs 110 pounds. We convert that 110. All right, 2.2, 50 kilograms. We multiply it by 18 units, and we come out with 900 units per hour. That's it. That's it. That's it. That's all you have to do with these. And that's the simplest format I'll give you on the test. These other ones, don't worry about those. All right. We're almost done, folks. Number 37. Number 37 is pretty simple. Cantrex, 65 milligrams is what's ordered. What is it? 65. What you have on hand
75.
is 75. Per what?
2 milliliters.
Per 2 milliliter. You see the whole thing? You see how it's on the end? It should, you would think it would be right next to the 75, right? You would think it would say 75 milligrams per 2 milliliter, but it's after the dosage. So it's 75 times 2. A lot of students missed this on the last exam. All right, so the answer is 1.7 milliliters. Ooh, yes. Come on. Finishing up. Number 38. Number 38, Nepsin is the order for 35. What you have available is,
20.
what's the rest?
For two.
Per 2 times 2. The answer comes out to 3.5 milliliters. All right. We're going to work this one from start to finish. All right. So, A. Okay, 39A. 39A. What is the child's weight in kilograms?
20.45.
20.45. We round it to the nearest tenth. 20.5 kilograms. So now we take that 20.5 kilograms. B is asking you, what is the safe 24-hour dosage? So it's 20.5 times 6, then 20.5 times 7.5. All right, so this one is 123 milligrams per dose, or 24-hour dose. 20.5 times 7.5 gives us 153.8 milligrams per dose. All right. C is what is a divided dose range. All right, so now we're going to take our daily dose and divide it. Okay, so the divided dose, according to the order, it says that this medicine is divided in 3 to 4 divided dosages. So which one do you choose? 3 or the 4?
4.
Why 4?
To make it even for 24 hours.
Because the doctor says every 8. So that's 3 times.
3.
So that's how you know which one to choose, according to what the doctor ordered. So it would be 3. So it would be 123 divided by 3. And we come out with 41 milligrams per dose. Then we take the 153.8, divide that by 3, and we come up with 51.26. We round that to the nearest tenth, 51.3 milligrams per dose. Okay. Is this dosage safe?
Yes.
Yes, the doctor's order is 45 milligrams, and it falls, 45 falls right in between here. So, hip hip hooray. You guys did very good, very good. All right, folks online, thanks for tuning in. I hope this was very helpful for you. And I will see you guys online. Jerry Jam, come in the session. I don't know. Turn it off.